In question 5a, we're asked to describe an experiment to accurately find the spring constant of a spring thought to reach its limit of proportionality at about 20 newtons. We're to include details of the necessary measurements and calculations and describe how we would reduce uncertainty in the measurements. Well, the spring would need to be suspended alongside a rule with a millimetre scale with a set square used to avoid parallax error. The initial length of the spring must be recorded so it can be taken away from the extended length to give the extension. The spring should then be loaded in 2 newton increments up to 20 newtons. This gives us 10 measurements in total. The readings should be repeated and a mean taken after eliminating any anomalies. As force is equal to the spring constant times the change in length, a graph of force against extension has the spring constant as the gradient. In B, we have 2 identical springs, each with a spring constant of 85 newtons per metre. They're shown arranged in parallel and in series. A load of 15 newtons is attached to each arrangement. In part 1, we need to find the extension of the parallel arrangement when the load is midway between the lower ends. Well, for the springs in parallel, the spring constant is twice the individual value, giving 170 newtons per metre. Change in length is force over spring constant. Putting in the values gives 0.088 metres. In part 2, we need to find the extension for the series arrangement. Well, for the springs in series, the spring constant is half the individual value. Again, doing the calculation, we get an extension of 0.35 metres. In part 3, we need to find the energy stored in the parallel arrangement. Well, energy is half times the force times the change in length, and this comes out at 0.66 joules. In part 4, without further calculation, we're to discuss whether the energy stored in the series arrangement will be less or more, or the same, as that in the parallel arrangement. Well, the force is the same, the extension is greater. As energy is half force times extension, the energy is greater in the series arrangement.